The runway lights fell away into a black Atlantic as Kenya Airways 5Y Ben lifted into the night, and then the cockpit screamed, "Stall!" In seconds, the pilots faced an impossible choice. Trust the warning that demanded a nose-down push, or trust their instincts that said climb. They pushed. Passengers felt the aircraft sink where it should have soared, the sea erasing the horizon and the truth. 10 would live to tell it. The secret that emerged from the wreckage was colder than the water. The warning that sealed their fate should never have sounded at all. On the evening of 30th January 2000, Félix Houphouët-Boigny International Airport moved with the unhurried choreography of a Sunday night operation. Airline agents called names in French and English, a chorus of boarding chimes threaded through the concourse, and heat from the Gulf of Guinea pressed against the terminal's glass. At Gate 4, Kenya Airways Flight 431, an Airbus A310-304 registered 5Y Ben, prepared for a routine hop east to Lagos, the first leg of an overnight journey that would continue on to Nairobi. It was a familiar pairing, a mid-sized twin-aisle workhorse and a profitable West African corridor, stitched together by migrant workers, traders, students, and families moving between Francophone and Anglophone hubs. The flight carried 179 people, 169 passengers and 10 crew, loaded by Ivorian ground handlers who had done this before. The manifest reflected the region: business travelers with overnight bags and paperwork, young men bound for jobs, mothers soothing overtired children, a few diplomats catching the last connection of the weekend. The crew, trained in Nairobi and operating within Kenya Airways' standard operating procedures for the Airbus A310, worked through checklists with the practiced tempo of a short-haul turn. Paperwork ticked over, a load sheet confirming balance within limits, fuel sufficient for the 45-minute sector, and contingencies. The weather brief noting light winds and a warm, humid night. Outside, the setting would demand attention even on a flawless departure. Abidjan's single runway, 0321, juts toward the open water, with the Ebrié Lagoon to the north and the Atlantic beyond. At night, the departure off runway 21 lays an aircraft over a featureless black expanse where few ground lights exist to give pilots the visual cues that help confirm attitude and climb. Controllers at Abidjan Tower worked both French and English, clearing late-night movements and clipped transmissions. The airport's beacons and the runway centerline lights presented a crisp path. Beyond the threshold, there was simply dark ocean. 5Y Ben itself carried no obvious drama. The A310-304 variant seats just over 200 in a typical two-class layout. Kenya Airways configured its cabin for dense regional demand. In the cockpit, two primary flight displays, conventional standby instruments, and the familiar Airbus thrust levers set the scene for a two-pilot operation. The aircraft had flown into Abidjan earlier and turned around on schedule. Maintenance logs in Nairobi had noted routine items in the days prior, none of which grounded the aircraft. For the passengers settling under the cabin lights, this would be an hour in the air, a drink service, and a quick descent into Lagos. Shortly after 9 p.m. local time, the final doors closed. The safety demonstration ran in two languages. The A310 pushed back, its CFM56 engines spinning up with a contained roar as tug lights bobbed in the darkness. Taxiway centerlines slid beneath the nose wheel. Then the crew held at the threshold of 21 for the last items: takeoff briefing, flap setting, and the expected call from the tower. In the tower cab, the controller cleared Kenya 431 for takeoff. Standard instrument departure, maintain runway heading initially. The jet entered the runway, crossing the last pools of yellow taxi light into the bright white of the centerline. To the right, the city's glow. Ahead, the nothingness of the Gulf. Thrust would rise, the airspeed tape would wake, and the A310 would surge into its takeoff roll. In moments, the flight would pass rotation speed and leave the concrete, trading the known for the night. What happened in those next seconds? How the power came up, how the aircraft pitched and climbed, and how a jolting oral warning invaded the cockpit would define the rest of the story. The A310 paused at the hold short line as if taking a breath. In the tower, the controller's clearance came clean and unambiguous. On the flight deck, the repeat back was steady, betraying no tension. With lights aligned to runway 21 and the night stretched wide beyond the threshold, the aircraft rolled forward and swung onto the center line. The thrust levers advanced. 2 turbofans wound through their harmonics, the airframe shuddering lightly as the brakes released. Beneath the cockpit windows, the runway's white lines strobed in a rapid march, a man-made horizon slipping under the nose toward the ink of the Gulf. Inside the cockpit, the choreography was as ordinary as it was critical. Airspeed alive. 80 knots, check. Hands guarded the thrust levers as the jet accelerated into humid air that sat heavy over the coast. V1 came and went, the committed speed, followed moments later by rotate. The pilot flying eased aft pressure on the side stick-like control column, and the nose lifted to a target pitch. In the cabin, gravity tilted as wheels left asphalt. The altimeter needles came alive, the attitude indicator showed a clean pitch-up, and the vertical speed nudged into positive territory. Positive rate, one pilot called. Gear up. From the tower's vantage point, the climb-out was a white riding light melting into blackness. Abidjan's city glow fell behind and to starboard. Ahead, there were no shoreline lamps or highway strings to help define the horizon. For the flight crew, the instruments were the horizon. The departure procedure called for a runway heading and an initial altitude that would hand them to radar soon after liftoff. There were no reported anomalies on the takeoff roll, no last-second calls of wind shear or birds, nothing to disturb the line from concrete to sky. On frequency, there was minimal chatter, late-night efficiency on both sides of the mic. The crew's first call after becoming airborne indicated a routine departure. The controller's response acknowledged them and handed them to the next phase with a standard instruction. If anyone in the tower suspected trouble in those opening seconds, it didn't carry across the radios. The A310 climbed into a sensory vacuum typical of ocean-facing airports at night. No stars glittered off the nose through a thin coastal haze, the water and sky blending into a single dark field, and cockpit windows framed only darkness. Then the cockpit layered in a new sound. The flight data and voice recorders would later place it within moments of liftoff, as the airplane reached only a few hundred feet above the water, the unmistakable oral enunciation of a stall. In Airbus parlance, the warning was designed to be unignorable, a synthetic voice paired with a persistent tone, indicating that the wing, if not already stalled, was nearing a dangerous angle of attack. It is an alarm that triggers deeply rehearsed reflexes. Pilots are trained to treat it as a fire on the nose. Lower the pitch, add thrust, prevent the break. There is no time for philosophical debate when the margin between flying and falling narrows. What the crew heard was not subtle. The warning cut through engine noise and checklist cadence, asserting itself as the cockpit's new metronome. The instant it sounded, the flight moved from rote to reactive. The pilots, who had just transitioned from earthbound acceleration to the fragile safety of the initial climb, were now confronted with a threat that, at that height, allowed almost no room for diagnosis. Crucially, the instruments did not all agree with the warning. The airspeed was not decaying precipitously. Pitch and power appeared in the envelope they expected for this weight and configuration. But the alarm's authority is born of hard lessons. Stall recoveries are drilled precisely because they brook no delay. The shock of that first stall smashed the smooth arc of departure. In the seconds that followed, procedures and instincts would collide with environment. Over a black, featureless ocean, with the runway lights shrinking behind them and no visual cues to cross-check against, the crew had to reconcile a shouted warning with a still-developing instrument picture. Their first inputs, their verbal coordination, and their adherence to training, or deviation from it, would be decisive. In the next beats, the flight would reveal how 2 experienced aviators managed power, pitch, and altitude when the airplane told them, insistently, that the wing could no longer be trusted. The first reaction was automatic. Thrust confirmed. With the warning still cutting through the cockpit, the pilot flying kept takeoff power in, a reflex consistent with training that treats energy as currency in any incipient stall. The nose came down. Not a shove at first, just a firm nudge to arrest what the alarm insisted was a dangerous angle. The vertical speed slackened. The airspeed ticked up. On an ordinary night, these would be the desired cues that a stall recovery was working. But this was no ordinary night. Outside the windscreen, there was only black. No shoreline to orient by, no ship's lights to hint at a horizon. Just the sensory void of an ocean departure with humid haze devoid of stars. In this environment, even correct inputs can feel wrong. The human vestibular system interprets acceleration as pitch up. Pilots call it the somatogravic illusion. With takeoff thrust pressing them back into their seats and no external references to contradict it, the sensation of the nose rising can be overpowering, compelling a counterintuitive push on the controls. Layer a stall warning over that illusion, and the psychological weight doubles. According to the flight recorders, the pitch began to oscillate, down to quiet the alarm, up to regain climb, then down again as the warning reasserted. Each cycle bled altitude margins that, this close to the water, could not be spared. On the flight deck, the callouts kept pace with the seesaw. One pilot guarded the power and scanned the tapes. The other managed pitch and configuration. The A310, unlike later fly-by-wire Airbuses, does not impose hard envelope protections. It will do as it is told within the limits of its aerodynamics. At flaps and slats set for takeoff, its wing will lift generously, but it will also accelerate briskly with thrust unchanged. The warning gave no quarter. It did not taper as speed rose. It did not relent when pitch was reduced into the zone where pilots are taught a stall cannot exist. That mismatch, an alarm that would not silence and instruments that did not paint a classic stall, forced the crew into a narrow cognitive corridor where they had to choose which signal to disbelieve. The black hole effect tightened that corridor further. On departures over dark terrain or water, pilots deprived of ground lighting often sense that they are higher than they are. They may fly a shallower than intended climb or push to chase comfort in the seat rather than numbers on the panel. Here, with acceleration strong and runway lights now behind and diminishing, the only honest brokers were the instruments. Yet even an unwavering instrument scan can fracture under startle. The captain and first officer had seconds to agree, not just on what was happening, but on who would do what next. Brief, overlapping commands, an acknowledgement, a minor retrim. The ordinary cockpit ballet turned staccato under the metronome of that single word. Engine parameters stayed healthy. There was no surge, no loss of thrust to complicate the picture. The airplane was not wallowing at the edge of controllability. It responded to inputs crisply, which in this regime meant that small changes in pitch produced large changes in flight path close to the surface. The record suggests that the crew tried to thread a needle, reduce pitch enough to appease the warning and build speed, then raise it to reclaim a steady climb, all while keeping the departure profile and configuration stable. The nose passed through level, dipped to a slight descent, came back up, each motion consuming precious altitude and time. In the cabin, the sequence translated into a disconcerting roller coaster. The brief lightness of climb, the stomach sink of a descent, the inconsistent engine roar that felt like acceleration without rise. The insistent logic of cockpit warnings can produce a hierarchy of attention that is hard to break. Stall is at the top because misunderstanding it can be fatal. Pilots are taught that ground proximity alerts demand immediate action as well. But when one system is accusing the wing and another the earth, deciding which to obey is a test pilots hope never to face. In Abidjan that night, the sensory environment made the choice even crueler. There were no lights on waves to betray height, no moonlit horizon to contradict the body's lie that up was down. The instruments held the truth, but the truth was now fragmented. Speed fine, pitch moderate, and yet a voice insisting on imminent aerodynamic failure. What happened next would hinge on seconds and feet. As the pitch oscillations continued, the airplane's path bent closer to the surface it had just left. In that shrinking margin, a second set of warnings began to intrude, vying for primacy against the siren already in the pilot's ears. The cockpit would soon be forced to adjudicate between the wing and the water, and the airplane, obedient to both physics and human inputs, would choose for them. As the oscillations widened, a second voice entered the cockpit, a blunt, mechanical admonition that left no ambiguity about the stakes. Sink rate. The ground proximity warning system had noticed what the pilots, fixated on airspeed and pitch, could not see outside the windows. The aircraft's path was bending back toward the surface. Seconds later came the escalation. Pull up! Pull up! Crashing into the already blaring stall alert that insisted the opposite, that more pitch would invite a wing to quit flying. Two imperatives, both anchored in fatal lessons, now competed in the narrowest of margins above black water. The A310 was still at takeoff thrust, engines steady and strong. With the nose eased to placate the stall warning, speed was not the issue, height was. The recorders would later show a shallow but persistent descent developing, the kind that steals altitude invisibly at first, and then all at once. In a simulator, pilots train for this ambush of senses. They are coached to trust the tapes and needles over their bodies. But human physiology in a dark, black hole departure can be stubborn, and here, the cockpit was flooded with high-urgency cues that contradicted each other. The stall alarm hewed to the primal fear of an aerodynamic break. The terrain system demanded a climb, when recent training had said a climb might be the worst response. Positive climb, one of them asked, more hopeful than certain. The instruments did not grant the reassurance that call seeks, altitude unwound. The radio remained silent. There was no mayday, no time to summarize a crisis to the tower. In the cabin, the cues translated to something visceral and disorienting. A sense of acceleration without ascent, the muffled cadence of commands over the public address-ready interphone, and then an unmistakable drop that pulled stomachs toward the floor. Some passengers would later recall seatbelts biting into hips, a flight attendant braced in the galley, and an eerie absence of anything to see beyond the window. GPWS does not negotiate. It repeats and intensifies when compliance is not detected. Pull up. Again and again, each call a metronome counting down. In the captain's hands, the control column transmitted small adjustments, tests, corrections, a bid to find the narrow band where both warnings might quiet. The stall alert did not relent. In one beat, the nose rose to recover climb, and the stall warning grew louder. In the next, the nose eased and airspeed ticked higher, but the GPWS hammered its case. The airplane obeyed physics with precision. With takeoff flaps still set and thrust high, it knifed through heavy night air toward a horizon no one could see. There is no drama to the sea when the sky and water are the same shade of black. No surf line to give depth, no reflection to telegraph proximity. The first external hint that the surface had come close was auditory, a change in engine note as pressure fields around the aircraft tightened, followed by an instant of white spume illuminated by the landing lights. Then impact, violent, flattening, a deceleration that split the airframe and tore inventory from overhead bins. The fuselage slammed and broke, water forcing through seams, lights dying in sequence. In the cockpit, recorders captured a final surge of alarms, drowned by the sound of rupture and rushing water, then nothing. On shore, the controller registered the disappearance as absence. A transponder target lost, a routine call that never came. Along the coastline, small boat fishermen who had tracked the larger silhouette of a departing jet saw a flash and heard a low, percussive crack roll across the water. Some cut their engines and listened for voices. Others steered toward the sound, guided by floating fragments that glowed briefly before darkness reclaimed them. The night became a spray of low human sounds, calls for help in multiple languages, the slap of debris and swell, the sputter of outboard motors gunning hard. The crash site lay within minutes of the runway, close enough that city lights still painted a faint smear on low clouds. Fuel slicks spread quickly, its smell sharp and immediate. Pieces of cabin and cargo bobbed, then dipped as waves passed. A handful of survivors surfaced amid that wreckage, shocked, injured, some clinging to seat cushions, some to each other. A few had the presence of mind to remove shoes, to swim clear of sinking sections, to call out into the dark. In the tower, alarms brought phones to life. The airport fire service and Ivorian Navy were alerted, and villagers on the shoreline lit torches and headlights to mark a rough bearing. The last sounds from the airplane had folded into the ocean, but the night did not stay silent. It filled with the scuff and shout of a rescue beginning in chaos, as fishermen converged and authorities scrambled to launch boats into the black. What unfolded in those hours would determine who lived long enough to tell investigators what they saw and felt, and who would be counted by divers at first light. The first boats reached the debris field before the sirens. Drawn by the flash and the sound of impact, fishermen from Port Bouet throttled toward the place where the sea had briefly boiled white, their wooden skiffs weaving through suitcases and insulation foam. They cut engines when the smell of fuel thickened the air and listened for human voices. What they heard were scattered pleas, French, English, Kiswahili, thin and far apart on the swell. The men moved by instinct, pulling bodies over gunwales, handing out spare shirts as makeshift slings, shouting to one another as currents pushed the wreckage toward the beach. At the airport, the tower's loss of the target triggered a cascade. Phones lifted off their cradles to the fire brigade, the National Navy, the Port Authority. A flurry of headlights raced along the coastal road and then slowed at the sand, where the sea's edge offered no easy launch. The first formal responders arrived with what they had: an inflatable boat, a pilot launch from the port, a battered Navy patrol craft, and fanned out under handheld spotlights that made tight tunnels of illumination in the black. By then, the fishermen had already pulled several survivors from the water and were ferrying them to shore, where police and volunteers carried them up the beach. In that zone between surf and streetlights, the rescue became triage. Ivorian Red Cross workers laid tarps on sand still warm from the day. Nurses in civilian clothes pressed towels to head wounds and searched for pulses under the collarbones of passengers still strapped into broken seat rows. A flight attendant, soaked and shivering, tried to convey a head count through chattering teeth. An airport doctor barked for more oxygen. The names of nearby hospitals, Trisheville, Côte, passed between radios, and ambulances backed toward the waterline so stretchers would not have to travel far. Above the scene, the night stayed windless, the surf steady, the fuel sheen a silent hazard that responders worked around with care. The geography of the crash, minutes from the runway, made the horror visible. By midnight, family members who had come to meet passengers on the scheduled Lagos leg had drifted toward the shoreline, held back by police tape, but close enough to see the procession of stretchers. Kenya Airways staff moved among them, trying to match names to faces and arrival statuses, to ink-smeared manifests. In Nairobi, the airline activated its emergency plan and dispatched a Team West. In Lagos, ground staff set up an information desk for a flight that wouldn't arrive. Calls leapt continents ahead of official lists. A cousin who had been at the airport, a fisherman's nephew with a mobile phone, a nurse who recognized a neighbor's child. By dawn, the scale had settled into numbers. 10 survivors, most of them pulled from the water within the first hour, were stabilized in Abidjan hospitals, some with broken limbs, others with the hypothermia that sneaks up in tropical seas after shock strips the body's defenses. Among them was at least one cabin crew member, able to describe a sudden plunge and water roaring into the fuselage. Forensic teams and divers began the slow cataloging of the dead. The tide and light made the work both easier and more intimate. Names and passports surfaced alongside armrests and meal carts. The sea gave up what it had taken quickly without sentiment, and by mid-morning the death toll, 169, was as stark as it was incomprehensible. Officials moved to put edges around the chaos. The transport minister held a brief, grave press conference at the airport, praising the fishermen whose speed had saved lives and acknowledging the sorrow that now linked Côte d'Ivoire to Kenya, Nigeria, and far beyond. The Navy marked off the wreck area for divers. Port cranes hove into view, lifting larger fuselage sections that had drifted into shallows. On the beach, volunteers carried cases of water and bundles of blankets, small acts under a sun that now revealed the debris field in full. Floating seat cushions like lily pads, a raft of papers, a child's shoe. The shock traveled fast through 2 continents connected by that route. Traders in Lagos markets expatriates in Abidjan offices, families in Nairobi who had seen off loved ones expecting a routine overnight. The arithmetic of safety that underwrites modern air travel, millions of flights uneventful, felt newly fragile. Yet even as grief took hold, the work bent toward answers. Divers searched not just for the missing, but for the airplane's memory, the orange canisters that record voices and numbers. By afternoon, recovery teams had their first lead on the location of the recorders, and investigators from Abidjan began coordinating with counterparts in Paris and Nairobi. The next phase would shift from rescue to explanation, as authorities sought to understand what had turned a standard departure into catastrophe. By mid-morning, the day after the crash, the search shifted from bodies to memory. Navy crews working a tight grid less than 2 nautical miles off Port Bouet tuned hydrophones to the thin metronomic ping of the underwater beacons mounted on the recorders. Divers followed a breadcrumb trail of torn cabin panels and wiring harnesses to a section of aft fuselage, resting on its side in shallow water the color of tea. Wedged beneath a tangle of cables, they found the first orange cylinder, the cockpit voice recorder, its paint scuffed, its beacon still ticking. The flight data recorder surfaced the same afternoon, hoisted up in a sling of cargo net and handed across to police on the quay as photographers crowded the pier. International procedure governed what happened next. Under ICAO Annex 13, Côte d'Ivoire, as the state of occurrence, led the investigation. The Transport Ministry's Air Accidents Unit opened a docket and invited accredited representatives from the states with equities, Kenya as operator and state of registry, France as state of design and manufacture for the Airbus A310, and through the engine supply chain, the United States and France again for the CFM56 partnership. The Bureau d'Enquêtes et d'Analyse in Paris dispatched a readout team. Airbus sent systems engineers familiar with the A310's stall warning and ground proximity logic. Kenya Airways Safety Office arrived with maintenance records and crew training files. The Ivorian gendarmerie secured wreckage as fishermen continued to tow in sections of fuselage and seats. The recorders traveled by air to the BEA's laboratories, where technicians began the delicate work of desalinating and baking out the units before opening them. In a clean room that looks more medical than mechanical, the magnetic tape from the CVR was spooled, digitized, and synchronized to Greenwich Mean Time. The FDR's solid-state memory yielded hundreds of parameters: airspeed, attitude, engine thrust settings, flap and slat positions, control inputs, and the timing and type of cockpit alerts. Investigators built a timeline second by second. They overlaid it with Abidjan radar tapes and ATC recordings, and with statements from survivors who remembered a hard push, a sense of acceleration, and the shouted commands of a crew working a problem in a hurry. On the ground, another team worked the wreckage map. The pattern suggested a largely intact aircraft at impact, a detail that pointed away from pre-breakup structural failure. Engines recovered with relatively undisturbed internal stages, and bent fan blades hinted at power on. Scorched edges were notably absent, consistent with no pre-impact fire. Weather data from the airport's sensors showed warm, still air, with no wind shear alarms and only a light haze over the coast. Terrorism, a reflex hypothesis in any crash, was quietly set aside when explosives residue tests returned negative. That left a narrower band of possibilities: misset weight and balance, an over-rotation leading to an aerodynamic stall, instrument failure, or a systems logic problem that misled the crew at the worst possible moment. The CVR furnished the first hard clue. Minutes into the transcript, the deep clatter of takeoff ambience gave way to a crisp, synthetic enunciation. The stall warning appeared almost immediately after liftoff, repeating over engine noise and checklist calls. The FDR showed thrust at takeoff power and an airspeed trend that did not comport with a classic stall. Pitch angles oscillated. The GPWS alerts chimed in later, a sequence that matched the fisherman's recollection of a brief climb followed by a sudden, unresolved descent. To the engineers, the juxtaposition was an invitation to interrogate the logic. Under what conditions would the A310's warning computer issue a stall alert in that configuration and phase of flight? Airbus engineers pulled system schematics for the A310's stall warning computer, a unit that integrates inputs from angle of attack vanes on the nose, airspeed, configuration, and sometimes accelerations to judge proximity to the aerodynamic boundary. Maintenance records from Nairobi and Abidjan were scrubbed for any mention of erratic angle of attack indications, heating issues, or previous write-ups related to flight control computers. The airline produced training syllabi and simulator profiles to show how crews were taught to respond to stall and terrain alerts after V1. Regulators watched these exchanges closely. If a logic pathway could produce a false stall call-out on takeoff, it was not only a local tragedy, but a global risk. Weeks turned into a measured cadence of lab notes and field updates. In Paris, BEA analysts aligned the two recorders precisely to reconstruct the cockpit environment. In Abidjan, divers marked the positions of major components on a grid to assess whether anything in the control system might have jammed or misrigged. Nothing obvious presented. In Nairobi, Kenya's Directorate of Civil Aviation began its own review of oversight and training for the Airbus fleet, fully aware the answers would be politically as well as technically freighted. The early consensus hardened around a single, uncomfortable descriptor: loss of control with no evident precipitating mechanical failure. That sharpened the focus further onto the information the pilots received and how they prioritized it. By the time the investigators convened their first joint technical review in Abidjan, they had a credible skeleton of the flight's last 90 seconds. The stall oral warning came early and stayed insistent. The airplane's energy state was not consistent with an incipient stall. The terrain warnings came late, when the nose was already in a shallow descent. It was a picture that demanded a granular look at the sensors and software that decide when to yell. The next tranche of analysis would target the angle of attack system and the stall warning computer's logic tables, a path that, if it held, would explain why an alarm meant to save a crew's life instead steered them into darkness. The answer took shape not as a single defective part, but as a chain of permissive logic. In the BEA's lab, the synchronized traces from the recorders told a consistent story: takeoff thrust set, a stable rotation to a normal pitch, and almost immediately, the oral stall enunciation, riding over an airspeed that was increasing. The engines stayed healthy. The flaps and slats remained in their scheduled positions. And there was no sign, no buffet, no speed decay of an aerodynamic stall in the making. Yet the warning fired and would not quit. That inconsistency sent engineers toward the only instruments that can conjure a stall in the computer's minds without one actually forming on the wing: the angle of attack vanes. The A310's stall warning computer weighs inputs from two vanes mounted on either side of the nose, then compares them with airspeed, configuration, and a small library of thresholds to decide when to speak. What the bench tests and data review exposed was an asymmetry the design allowed. In a narrow slice of flight right after liftoff, the system could accept a single vane's high-angle value as authoritative and generate the alert without reconciling it against the other side or against the aircraft's energy state. On 5Y Ben, one vane, damaged or internally faulted in a way that the crash did not erase, had produced a falsely high angle of attack output at the moment the pilots rotated. The stall warning computer took that number at face value. It did exactly what it was designed to do, but on bad information. Investigators did not find a smoking gun inside the computer. Its self-tests were clean. Its calibration matched factory spec. Nor did they uncover weather that could plausibly ice a heated vane in the tropics, or a bird strike that would have left physical evidence. The probable scenario they assembled was more prosaic and more troubling: an intermittent fault in the vane, contamination, wear, or an internal discontinuity that passed pre-flight checks but spiked under the accelerations of takeoff. Because the logic then in use did not demand agreement between sides or impose a stronger inhibit immediately after weight-off wheels, a spurious oral warning could penetrate the cockpit at the worst possible height. The human factors were not absolved. They were framed. In simulator recreation, the same pattern unfolded when the false alarm was injected. Pilots, startled by the call-out just as the horizon disappeared, lowered the nose to protect the wing, then became trapped between a warning that would not silence and a terrain system that spoke too late. The black hole departure over water magnified the vulnerability. The accident report would later call the warning erroneous and the crew's reaction inappropriate to the actual flight conditions. But it also made clear that neither adjective exists in a vacuum. The system had granted a faulty sensor the power to shout down a normal takeoff. Responses followed quickly. Airbus issued operational guidance reminding crews that stall warning immediately after liftoff with normal thrust and airspeed must be treated with caution and cross-checked on instruments. Ground proximity warnings retained primacy when conflict arose close to the surface. A modification to the stall warning logic, reflected first in service bulletins and then in regulatory directives, added post-liftoff inhibits and more stringent cross-channel validation so that one bad vein could not trigger an oral alert alone. Airlines, including Kenya Airways, incorporated targeted training on false stall indications, emphasizing instrument discipline in black hole departures and the hierarchy of cockpit cautions. By the time the Ivorian-led team released its conclusions, the narrative had settled into a disquieting clarity. A survivable phase of flight compromised by a false warning that should not have sounded, and by a design that allowed it to sound when pilots were least able to diagnose it. The technical fixes and training changes could not rewrite what happened off Abidjan, but they aimed to make sure the same trap would not spring again. The final task was to translate these findings into durable lessons and to reckon with what the industry owed the families who had demanded to know how a routine takeoff became a night in the sea.